In this video, we're asked to write a method called depthSum, which will return the sum of the values stored in a binary tree of integers weighted by the depth of each value. What does this mean? Well, the way we divide up the depth is we say, okay, so we're going to look at it in terms of levels. So at the top we have level 1, level 2, level 3, level 4, and level 5. You can imagine this as, okay, up here, the water level is 1 foot deep. Here, at this line, it's going to be 2 feet deep, 3 feet deep, 4 feet deep, and so forth. So what are we actually going to do in this depthSum method? Well, what we're going to do is we're going to take the level number and we're going to multiply it with the total summation of the data values that are found from the leaves on these levels. So, for example, if we're looking at level 1 here, then we're just looking at 1 times 2. But if we're looking at something along the lines of level 3, then we're looking at 3 times the, we're looking at 3 times the sum of the values that are on this level here. So it's 3 times 7 plus 6, which is 3 times 13, which should be 39. And anyhow, so now that we've kind of got a general idea of what we need to do here, we can actually start writing up our method. So let's just deal with a pseudocode here. So what do we know? We're going to return in type of integer because we're going to be multiplying the level times the sum of data values per level. Okay, that's good. So let's deal with public method first. So depthSum is going to just, once again, we're gonna let our private method do all the heavy lifting here because we're cool like that. So what do we want to do? Let's think about it. We want to look at 2 individual parameters here. Why? Because we have a level that we're looking at, and then we have data values from leaves that we're looking at. So you could actually add the parameters in any order that you want, but for simplicity's sake, I'm going to say I'm going to look at the overall node first, and then I'm going to look at level 1. Why 1? Because it's a starting point. So nothing special about it. It's just that's kind of the bare minimum, because I mean there's no level 0 in this sort of thing. So whoops. I'm really tired here. So I did not know that I accidentally wrote the return type. I didn't mean to write double return type. I get an error saying that I'd never actually be able to reach that point. Well, actually, I don't think I get an error. I think it would just return the depthSum. It probably just wouldn't compile in general. So we're gonna create our private in depthSum method here, and because it's taking overall node, well, actually, yeah, overall root, because that's what we've been doing in the last few videos. So we're going to take an int tree node. We're going to call that root. And we're going to take an integer, and we're not creative, so we're going to do what everybody else does, and we're going to call it type n. So what are the cases that we have to look at here? Well, let's look at the base case. Well, first of all, if root is equal to null, then we just return 0. Because we have nothing to look at here. Struggling. Really struggling. Do we have any other special cases? I'd say no. Mainly because we don't care as to whether or not there's a left branch or a right branch or no branches at all, because we're we're just going to be continuing. We're just going to be looking at each individual root to see its values, so we don't actually care about whether or not there's a left or a right side. But we are going to return the left and right side, as you guys will see in a second. So if root is equal to null, as we said before, it's our base case, we'll return 0 because there's no summation there, there's nothing to look at. We don't have another special case, so we're just going to go to the if statement. What are we going to return here? We're going to return n, because n represents the level we're looking at, times root.data, because, for example here, our n happens to be 1, and this is our root.data on that level. And then we're going to look at the left side. And then we're going to increase the size by the level by 1, because we actually want to move down the binary tree. And then we're going to look at the right side here. So let me actually just copy this. I am really lazy. And we go down the right side so that we can look down the right side of the branch. And that will do it for this method. See you guys in the next video.